the conformations of ethane and I asked you to draw that of propane and butane, and ask you to compare that of ethane and propane, and then draw that of butane. Okay, now this comparison you have to do it by yourself. I will just give you an idea about the conformation of butane today. Now look at butane. Butane is CH3, CH2, CH2, CH3. Now I asked you to view the molecule along C2, C3 axis. What is the meaning? The meaning is this is second carbon, this is the third carbon. So you have to view the molecule from here along this. That means your eye should be here, kept here, and view it. So if I do that, how will I draw the molecule? I have to put my H here, this H here, and then one H here, the other H here, and the CH3 here. Okay, now see this. Now what should I do? I should draw the numerical projection of this. Then only we can see the dihedral angle. Now I'm observing from this side. I'm drawing the numerical projection down over here. See here. You have the CH3 and CH3 both are down. Both are one above the other, and H and H. And here is H, here is H. Okay. Now for convenience, I will draw this in the opposite direction. It's for my own convenience. You will understand very better. I have the CH3 here, CH3 here, H, H, and I will have H here and H here. See, this is now see here the CH3 and the CH3, they are one behind the other. Hence dihedral angle is 0. This is one behind the other. So the dihedral angle is 0. And see here, the CH3 is very close to each other. So there is steric interaction, very high level of steric interaction. Very high level of steric interaction here because they are very close to each other. So, and this is the form in which the CH3 groups are as close as possible. Okay, so this will be having the maximum energy in the molecule. This is going to have the maximum energy. So, let me draw the energy profile diagram here. Okay, my drawing is not very good. Let me put this graph like this. Okay, now, so this is the maximum energy form when the dihedral angle is 0. So along the x-axis you have dihedral angle, and along the y-axis you have energy of the conformation. Okay, this is the completely eclipsed conformation. This is the eclipsed one. Dihedral angle is 0, and you have this level of energy. Clear? Now you start rotating the back carbon clockwise. Okay. When you rotate this back carbon clockwise by 1 degree, 2 degree, 3 degree, what happens is these two CH3 groups start moving away from each other. What is the consequence? Energy of the system comes down. It becomes more stable. So you will have this comes down, next, like this it comes down till it reaches this level. Okay. Now onwards we will draw only the two CH3 groups. All others will not draw for convenience. We will draw two CH3 groups, while all others are hydrogens. Now see here. Now what is the dihedral angle? This is the dihedral angle, 60. Okay, dihedral angle is 60, and you have a staggered conformation. See here, this is staggered, and this one is eclipsed. So here you get the first staggered conformation, where the two CH3 groups are at 90 degrees to each other. So you will get a minimum energy. So this is at 60 degrees. Now continue rotation. Continue rotation. When you continue the rotation, when it reaches 120 degrees, see here, then the H and the CH3 comes closer. The H and the CH3 comes closer. CH3 and H. Again, it is eclipsed. Remember, all the eclipse conformations are having maximum energy. All eclipse will be having maximum energy, and all staggered will be having the minimum energy. So here is a first minimum at 60. Now next maximum. Now this, compare this and this. Compare these two. Which do you think will be having higher energy? Which will be having a lower energy? Think about it. Which do you think will be having a higher energy, and which will be having a lower energy? Definitely, this will be having higher energy. This will be having lower energy, because the CH3 groups are away from each other. But this CH3 and this H are eclipsed. This CH3 and this H are eclipsed, and they are very close. So that will be having a maximum less than that of 0 degree. Okay. So let me draw this way. So this is the first maxima. Now this is the second maxima at 120 degree. Okay. Now let's move again 60 degree. Move again at 60 degree. CH3, CH3. Now, both the CH3 groups are opposite to each other. They're exactly opposite. Maximum distance from here to here. Least interaction and most stable. Okay, so as you move from here to here, the energy keep on decreasing. They keep on decreasing and come to a very low value here. So this is 180. Okay, it is lower than this value. Now again, from here, it is still getting rotated to this side. And you get next eclipse conformation. Here you have hydrogen again and the CH3. Here you have the CH. So again you get a maximum, just like the other one. 120 degree and this are the same. 120, this is the 120 value. This is 120, see here. This is on the right, CH3 is on the right side. Here the CH3 is on the left side, that's only difference. So you will have the same energy level here. So this is 240. 240. Now move this, you'll get the CH3 here and CH3 here. Okay. Now see, this and this are the same. Same energy. See this. Only thing is, in one of them CH3 is on the right hand side, the other is on the left hand side. And these two forms are called gauge conformation. G-A-U-C-H. Gauge conformation. It's also called as Q. S-K-E-W. All these words will come in there. If it comes on the exam, you should not get confused. It's also called as Q conformation or gauge conformation. Okay, so you have this level of energy, same as the first, this and this are the same. Right? Now you move this again to this, you will reach the same as you started with. So this is 300. This is 360. You reach the original position. So you have two energy maxima and two energy minima. The two energy minima are the anti-conformation and skew conformation. This is Q and this is anti, where the dihedral angle is 180. Okay, and here it is eclipse conformation. Both are syn. Syn means on the same side. Both are syn and eclipse conformation. So these two are stable forms of butane, and this butane much exists in these forms, either in the skew form or in the anti form. Very rarely, very few percentage will be there in the eclipse conformation. So this is the conformation analysis of butane. Let us look at now the most important study on conformation in organic chemistry is people play a lot with cyclohexane, cyclohexane. Now you know what is cyclohexane. Cyclohexane has got 6 carbons. And remember, this molecule is not planar. It exists in a chair form. Make sure that you draw the correct cyclohexane in the correct fashion. Pretty difficult. Most of the textbook will teach you how to draw. Okay. Make sure that you don't draw in any other fashion. What you can do is, see here, draw 4 lines, 1, 2, 3, and 4. Okay. Now, you start from here. See here. These two are parallel. These two are parallel, 1 and 2. And these two are parallel. 3 sets of parallel lines. 3 sets of parallel. And the upper one and lower tips should touch at the same line, nearly the same line. So try to draw this in this fashion only. This is what you have to look into. This should be in the same line, and this also should be in the same line. So I will suggest you draw 2 lines first, then connect. See, something like this you can draw. This is very much, don't try to draw like this. This will confuse you. Don't try to draw this way or even this way. All this will confuse you. So try to draw cyclohexane in a nearly perfect fashion. Otherwise, you will get confused with whether this bond is equatorial or axial, whether it is up or down. Okay, now let me draw it here. Let me draw the cyclohexane here. I know it is many times it's pretty difficult to draw a cyclohexane. Now let me put the bonds. Each carbon, there are 2 hydrogens. On each carbon, you have 2 hydrogens. And you can see here, this is something like a chair. This is the head of the chair. And this is the tail part of it. Okay, it is something like you are sitting with your foot like this. This is your foot. Okay, this is your knee. Okay, this is the foot. And these are your buttocks. And this is your head. As if you are sitting in an easy chair. Right? An easy chair like the old fashioned. Now, here you have two hydrogens. One, and you can see here, these 3 carbons. See, this point and this point are pointing upwards. So you call them as up carbons. So this is an up carbon. This also is an up carbon. This also is an up carbon. This you will call as a down carbon, and a down carbon. Okay, this is very important for putting that different groups in the proper perspective. You have to give the stereochemistry has to match. Now, you can see here on the up carbon you have one up bond. This is the up bond pointing up. Up. And look here on the down carbon you have the down bonds. These are the three down carbons on which these are the down bonds. Okay. Now suppose this is the plane of the ring. See the cyclohexane we have kept in a plane perpendicular to the plane of the bone. Let me make the model and show it to you. Otherwise, it will be very difficult to understand. One second. Let me make the model. I forgot to make the model first. Or I do want to. I'll make the model tomorrow. Today, I'll make the model and explain it tomorrow. Today, I have to stop a little early. Now, let me just explain this first. So you have the up, on the up carbon, you have three up bonds. On the down carbon, you have three down bonds. Okay, all these are parallel to each other. See here, 3 and 3. All are parallel to each other, either pointing up or pointing down. So those which are perpendicular to the plane of this ring, these, see this is the plane of the ring. These bonds are perpendicular to the plane of the ring. See here, this bond is pointing down. This is the plane. These bonds are pointing up, so they are perpendicular to the plane of the ring. Okay, this ring I will consider this way. If I draw the planar structure of this ring, see here. This is the planar structure. Cyclohexane. Okay, this is the planar structure, and each you have sides on the top, bottom. This is the planar structure. In reality, it is not planar. You know that is why we are putting it. Yeah. But in the planar structure, this is the way you found. Now consider this and this. That's why I showed you this is the plane of the plane perpendicular to this is a plane of the ring. Just a plane of the ring here. Now this, so here you have the hydrogen which is pointing up, pointing up, pointing up, pointing down, down, and down. So you can, I will just write this in a brief way. Which are the axial bonds? I will draw in a very brief way which are the axial and which are the equatorial bonds. Takes a little time. So this one is very slow. Well, internet is not very fast. Probably that's why it takes time to wipe out. Okay. Now let me put the carbon. Let me put the high bond. Carbon bond. Nature of the bond. Now see here. We are talking about the up carbon. See here. Up carbon. Up bond. Axial. The up carbon, the up bond and the up carbon, it is axial. Similarly, down bond, down carbon, down bond is also axial. whatever we have drawn is axial. Okay, so this is axial, all these are axial. Now, here I have to draw the next bond. Please draw 120 degree to this. Always 120 degree to each other. This is 120. So this is a down bond. Now here, this is the down bond. So draw a line 120 to this. 120. See, this is 120. So this is the up bond here. See very carefully. This is down, therefore this is up. And now, what about here? You have drawn the up bond. So the down bond, 120 degree. This is 120. This is a down bond. Now here, this is a down carbon. A down bond is axial. Now you have 120 degree. You have an up bond. So these bonds which I have just now shown, they are projecting along the plane of the ring, just like a bird which is flying, a flying bird. See how a flying the flying bird will have its what is that? Its wings parallel. Suppose you have the bird like this. You have the bird, its wings will be on this side. Or you take an aeroplane. You take an aeroplane. If you look at an aeroplane from the front, the wings will be parallel to this body. Neither up nor down. So those which are in the plane of this ring, they are called equatorial bonds. So this is equatorial. Now you describe this up carbon, down bond. Up carbon, down bond is equatorial. Similarly, down carbon, see here, this is a down carbon, this is the up bond. Down carbon, up bond is equatorial. Is that clear? So keep this table in your mind while drawing the structure of cyclone. We'll put it as a slogan: up, up, axial, down, down, axial. Up, down, equatorial, and down, up, equatorial. Is it clear? Okay. So just revise this. Today I will stop a bit earlier. I was late to start. I actually wanted to start earlier. I forgot. I was a little busy. So please forgive me for that. Okay. Thank you. I'll stop it today. We'll continue tomorrow at